Today we are going to be solving rate problems, and just like distance, rate, and time problems, that's a little formula we use, we're going to use a formula for these problems as well. And it's going to be job equals rate times by the time at which we're working. Now a job completion is like 100%. We consider a job being done if it's 100% complete. Well, if we write 100% as a decimal, it's just the number 1. And what we're going to do is take their rates, the rate at which Sydney can do the job and the rate at which Sarah can do the job. So we're going to take Sydney's rate, and we also take Sarah's rate, and then we're going to end up adding those two rates together at which they do the job. And then we're going to multiply it by time. Now we're not going to know this time because that's what they're asking for. See, how long will it take? How long will it take? They're asking about time. And so that's what we want to try to find. And so let's take a look at Sydney's rate. Sydney does the job in 50 minutes. Well, how much does she get done? What part of the job does she get done each minute? Well, after 50 minutes, the job is done. So each minute she's getting 1/50th of the job done. Sarah, well, she's getting 1/40th of the job done each minute. After 40 minutes, it's totally done. 40 out of 40 parts are done, and it's 100% complete. So if we add their rates together, then we multiply by time, that'll give us 100%. And that's what we're trying to do. So let's set up our equation that way. 1 equals 1/50th plus 1/40th. And then we're going to add those two together and multiply by time. And that's what we're trying to solve for, actually. So what I need to do is I need to come up with a common denominator. They both have a factor of 10, so I don't need to multiply by that. But the 50 needs a 4, and the 40 needs a 5. So I'm going to multiply across. And so what I've got now is 1 equals 4/50ths plus 5, actually not 50ths anymore, that's 200ths, so let's fix that real quick. So 4 over 200, because I have to multiply both the top and the bottom by 4, plus 5 over 200 equals, and that's what we're going to try finding in the next step here, times by time equals 1. So we go ahead and do the next part, which is to add these two together, and we end up with 1 equals 9 over 200 times by time. So together, this is their rate. 9/200ths of the job gets done each minute. Well, let's find out what that time represents. Well, in order to solve for t, I'm going to multiply by the reciprocal. Do the same thing on this side, so times by 200 over 9. And so when I do that, I've got t equals 209ths. Well, it'd be nice to know what that represents, so let's do some division. So 9 into 200. Well, 9 goes into 20. We have 2 times. Makes 18 left over. We get a 2 left over. Again, it looks like it's going to be 22.2 repeated. And so what we'll say is the time in which it takes is 22. We'll just round to the nearest tenth. 22.2 minutes is how fast it would take them if they're working together. So this next problem is exactly the same type, just different numbers and different names. Ted does the job in 30 minutes. Ed does the same job in 45 minutes. How long if they work together? How long means time is what we're trying to solve for. So let's set it up. Well, Ted's rate is 1 out of 30. That's his rate right here. And Ed's rate, well, his is 1 out of 45 parts get done each minute. Ted does a little faster. 1 out of 30 parts gets done each minute. After 30 minutes, Ted's done. After 45 minutes, Ed's done. Well, together they're going to do it faster because we're adding the rates together. Finding out how fast they can do it together, you got to find their combined rate. And so I look at these numbers and I see 15 goes into these numbers. If I just multiply this one by 2, actually if I multiply this one by 3, let's go by 3, and this one by 2, that'll give me the same denominator. And so I go ahead and do that work. So I end up with 1 equals, this makes 3/90ths plus 2/90, and this is multiplied by time. And so we'll take a look at the next part here. So I add the numerators together, and I end up with this. 1 equals 5/90 t. So what this means is 5 parts out of 90 get done each minute when Ted and Ed are working together. So to solve this, all I'm going to do is multiply by the reciprocal, 95ths. And you see what will happen is the 5's will end up canceling, the 90's cancel, so I'm just left with t. So I've got my answer, 95ths, but we need to know what that represents. So off to the side, you just do the division. 5 into 90. 5 goes into 9 one time. With 4 left over, 5 goes into 40 8 times. There it is, 18 minutes. So 18 minutes is the time it takes them when they're working together. Well, the next two problems are a little bit different, so let's take a look at these. Same sort of concept in the beginning, though. John does the job in 20 minutes, so his rate is 1/20. Ed does the job in 30 minutes, so Ed's rate is going to end up being 1/30. And they want to know how long it will take to do the job if the job was 3 times the size, and they're working together as well, so working together. So we're going to say 1 equals 1/20 plus 1/30. This will give us the time at which it take to do just one job together. So what I need to do is come up with that common denominator. See, they both have a factor of 10, so the factor 20 does not have is 3. The factor 30 does not have is 2. So I go ahead and multiply across, and this is what I get. I get 3/60 plus 2/60. And that's getting multiplied by the time. This all equals 1. And so that makes a total of 5/60. So 1 equals 5/60 t. And so what that means is 5 parts of the job get done out of 60 each minute when they work together. So if I divide by the number I'm multiplying by the reciprocal, it means the same thing. So I end up with 65ths, and then I just do that division off to the side. So 5 goes into 60, we have 12 times. So 12 minutes, that's the time it takes them to do one job. But now they need to do a job that's 3 times the size. So what we need to do, 3 times means that we're going to do exactly that. We're going to times. We're going to multiply. So 3 times 12 equals 36 minutes. And so that's the time it takes them to do a job 3 times as long. Same thing on this one. It takes 20 minutes for pipe A to fill the tank, 15 minutes for pipe B to fill the same tank. How long if the 2 pipes are working together to fill a tank that's twice as large? Well, what's twice mean? Twice means 2 times. 2 times as large. So let's find the rate at which they do one job together. And so it's just going to be their rate, 1/20 plus 1/15. Those are their rates. We're going to add them together to find the rate at which they're working together times by time, which is what we're going to try solving for. So I need to come up with a common denominator. They both have a factor of 5, so this one's missing 3, and 15 is missing 4. So I multiply it by 4/4. So now what I have is 1 equals, I have 3/60 plus 4/60. Those get added together times by time. And so on this side I have 1 equals 7/60 t. And so what I need to do to solve is just multiply by the reciprocal. And that'll get the t by itself. So do the same thing on this side. So 60/7. So I get 67ths is my answer, but I'm not done yet. I want to figure out what that comes close to. But before I actually do that, we want to find a tank that's twice as large. This is not going to go in evenly, so I'm going to go ahead and multiply it right now. So I'm going to take that 67ths and times by 2. 2 because it's twice as large, and so this makes 1/20/7. Now I'm going to do that division. 7 into 1/20. So 7 goes into 12 just one time. With 5 left over, it goes into 50 7 times with just 1 left over. So it can add a decimal point, bring that down, it goes into 10 one time. So about, now That's just about, because I approximated it, because I rounded to that nearest tenth, and I know it's just going to be about 17.1 minutes to fill a tank that's twice as large. So those are the types of problems you'll see on tonight's homework. Good luck.